So we're going to go through and look at these notes on the mole. You should have that document open in Notability and then be watching the lecture on the other side of your screen or on a different device. So, like you saw in the videos yesterday, the mole is sometimes used like a dozen. Okay, so sometimes it's called the chemist's dozen. Sometimes we write out the entire word, M-O-L-E. Sometimes, if we want to abbreviate it, we write M-O-L. We can't use M because that's meter. We can't use M-O because that's mole, or that's, month, or it's used elsewhere. So we go with M-O-L. That's our abbreviation. So you can either, if you see MOL, that's just the abbreviation for mole. It is a counting unit. So it's sort of like the word dozen. So when we say dozen, we mean 12. When we say mole, we mean a number. But it's a big number, right? It's 6.022 times 10 to the 23rd. A very, very large number. Sometimes we call this number Avogadro's number in honor of Amadeo Avogadro, who was one of the earliest scientists to look at the number of particles in gases. So, just like we know, when we say a dozen eggs, that means 12 eggs. When we say a mole of water molecules, we mean 6.022 times 10 to the 23rd water molecules. Is anyone still writing? So, one of the things that was nice about the videos that you watched yesterday is that they had graphics to kind of demonstrate how big a mole is. It's a really, really big number. So, some estimates. So, a mole is about the number of grains of sand on all the beaches in the entire world. It's about the number of 8-ounce glasses of water in all the oceans in the world. And if we had a mole of paper clips chained together, it would wrap around the Earth 400 trillion times. It's a gigantic number. Now, one thing that you should have picked up from the video was that even though the mole is a really, really big number, if I have a mole of water molecules, that doesn't make very much because molecules and atoms are so tiny. So a mole of water molecules is about 1/10 of a cup of water. So we use the mole to count atoms and molecules because it is large enough to conveniently weigh or measure them in the lab. A lot of what we do in chemistry has to do with individual atoms or ions. So you saw, like, when we wrote formulas, we were using individual ions. When we write out chemical equations and balance them, we're going to be talking about individual atoms and molecules. But that's not how we work in the lab because they're too small. There's no way we could work with just one atom or one molecule. And so we have to think in terms of groups of molecules and atoms in the lab. And so that's where the mole comes in, because the mole tells us how many. We have a number attached to the mole to tell us how many, but as we're going to find out, we also have mass attached to the mole of different elements. So we're going to use this to help us to count in the lab. So what we call this next thing is called molar mass. So the average atomic mass on the periodic table is the mass in grams of 1 mole of atoms of each element. And so if you look at different elements, like, for example, hydrogen has an atomic mass of 1.01, and carbon has an average atomic mass of 12.01. So that means that a mole of hydrogen atoms weighs 1.01 grams, and a mole of carbon atoms weighs 12.01 grams. So the same number of atoms has different masses because carbon atoms are heavier than hydrogen atoms. So when we say we have a mole of hydrogen atoms and a mole of carbon atoms, we have the same number of each type of atom, but they are different masses because the atoms are different sizes. It's kind of like if you had a dozen ping pong balls and a dozen bowling balls. You would have the same number of ping pong balls and bowling balls. You would have 12 of each, but the bowling balls would be much heavier because each bowling ball is heavier than each ping pong ball. And so when we talk about molar mass, our definition is the mass in grams of 1 mole of a substance. And so that means if I look at my periodic table, I'm looking at the average atomic mass, 12.01 grams. That's the mass of 1 mole of carbon atoms. If I look up copper on the periodic table, my average atomic mass is 63.55. That number in grams is the mass of 1 mole of copper atoms. So if I weigh out my copper and I know the mass of copper that I have, I can figure out how many copper atoms there are, because 1 mole always weighs 63.55 grams. If I had carbon, 1 mole of carbon atoms weighs 12.01 grams. So look at your periodic table and see if you can figure out the mass of 1 mole of silver, 1 mole of cesium, and 1 mole of oxygen molecules, O2. So take just a minute to figure that out. Okay, so if you looked up silver on the periodic table, you'll see that its average atomic mass is 107.87 grams. And so that is the mass of 1 mole of silver. If you looked up cesium on the periodic table, 1 mole of cesium weighs 132.91 grams. Now this third one's a tricky one, because if we were to look up oxygen on the periodic table, oxygen has an atomic mass of 16 grams. But this is O2, so there are 2 atoms of oxygen in each molecule. So we have to multiply 16 by 2 to get the mass of a mole of oxygen molecules. So what if I want to find the molar mass of any molecule? So remember, the molar mass is the mass in grams of 1 mole of a substance. And the average atomic mass on the periodic table is equal to the mass in grams of 1 mole of atoms of each element. So you need a periodic table to do these problems, and it's also helpful to have a calculator. And so here are the steps to calculate the molar mass of a molecule. First, we're going to count the number of each type of atom in our molecule. Then, we're going to multiply the number of atoms for each element by the average atomic mass in grams for that element that we find on the periodic table. Then, after we've multiplied all of those out, we are going to add all of the masses together. So the total mass for each element in the compound. When you write your answer for these problems, your units are going to be grams per mole, or G over MOL, grams over moles. Because this is telling me the number of grams in 1 mole of the substance. So we're going to do some practice problems together. And then your homework is going to be to calculate some molar masses on your own. When you do your homework, you need to show, at the very least, steps 3 and 4. So I need to see the numbers that you have added together to get the molar mass. Okay, so you can do this on your calculator, but I need to see the masses for each element and how you added them together to get your answer. And I need to see the units grams over moles. So here's our example. So we're going to follow the steps. So we're going to count the number of each type of atom in our molecule. So we've got sodium. We've got 2 atoms, because remember, the subscript after the sodium tells me that I have 2 sodium atoms. Then I'm going to count my carbons. I have 1 carbon. And then I'm going to count my oxygens, and I've got 3 of those. So now for each element, I'm going to take the number of atoms times the average atomic mass on the periodic table. So 2 times 22.99 is 45.98. 1 times 12.01 is 12.01. And 3 times 16 is 48. So I'm going to add all these together to get my total mass. And I get 105.99, and my units are grams per mole. So in terms of what work you have to show, I have to see this. That's the information that you need to show me for your calculations. Are there any questions? Now in your notes there are a whole bunch of practice problems, and we're only going to do a few of these together because we don't have as much time as we need to go through all of them. So I want you to notice here that nitrogen, the mass of 1 mole of nitrogen atoms is 14.01 grams. That means if I have 6.022 times 10 to the 23rd atoms of nitrogen, it's going to weigh 14.01 grams. Remember, the moles tell me how many, and the mass tells me how heavy. If I have a mole of nitrogen molecules and each molecule has 2 atoms in it, I'm going to just double that amount because I'm going to have twice as many nitrogen atoms. Sodium chloride. We've got 1 atom of sodium and 1 atom of chlorine. And so we're just going to add those 2 numbers together. For number 4, we're going to have to multiply the atomic mass of carbon by 12, the atomic mass of hydrogen by 22, and the atomic mass of oxygen by 11 to get our answer. Number 5 is tricky, and you have to be very careful when you have these polyatomic ions. Notice this 3 down here. That means I have 3 atoms of magnesium. Notice that I've got a 2 outside the parentheses. That's going to multiply everything inside the parentheses by 2. So that means that I'm going to end up having 2 phosphorus atoms and 8 oxygen atoms in this compound. So once I count them, then I'm going to multiply them by the average atomic mass on the periodic table. So I'm going to give you the answer for number 6. You might have some different ones in your notes, I'm not sure. This is your molar mass for number 6. So notice in number 6 you have 10 calcium atoms, 6 phosphorus atoms, and then our oxygen is in 2 different places. We have oxygen here and here. So we're going to do 6 times 4 is 24 plus 2 more. So we have 26 oxygens. So 10 calciums, 6 phosphorus, 26 oxygens, and 2 hydrogens in that compound. So your homework for tonight is going to be calculating molar masses. You will also be required to either write the name or the formula of the compound. Please look at the directions and follow them correctly. Please make sure that you show your work and that you use units for your answer. There's also a Tyler DeWitt video there in case you need someone to sort of walk you through it again. That might be helpful for some people.